Today we are going to go over 7.8 part 2, improper integrals. Last lesson we learned improper integrals where the boundaries are infinity or negative infinity. In this lesson we are going to deal with some type of problems where we have singularities. So if you look at example 1, so in example 1, the integrand is square root of 1 minus 1 over x. As we know, the denominator cannot be 0, so x cannot be 1. And if you look at the boundary here, 1 is right here. So in this case, we call x equals 1 is a singularity here. So how to do problems with singularity? So first, we evaluate this integral without boundaries. So integration 1 over 1 minus x dx. We take the integral. How do we integrate it? It's the same thing as 1 over square root of 1 minus x dx. You can use u substitution. So u equals 1 minus x, du equals negative dx. So this will be integration. Write it here. Negative du over square root of u. It's negative integration u to negative 1/2 du, which is negative 2 u to the 1/2, which is negative 2, 1 minus x to the 1/2. So after we take the antiderivative, next we are going to include the boundaries here. So integration 0 to 1. Because x cannot be 1, so the 1 we have to do something with this number 1. The boundary is from 0 to 1. So instead of doing 1, we are going to write 1 minus here because it's from 0 to 1, so the x value will approach 1 from the left. So this is the problem. And this will be 2, negative 2, 1 minus x, 0 to 1 minus. Now we are going to use the limit x, we plug 1 minus in, so it's negative 2, 1 minus x, and then we can plug 0 in, so it's negative 2. So this constant we don't have to worry, we have to evaluate the limit here. So as x approaches 1 from the left, we can plug 1 directly in, so give us 0 plus 2. So the final answer is 2. So the integral converges. So it doesn't matter left, one-sided limit or limit, you can plug it in. If you plug it in, you get a number, then that's your answer. Let's have a look at example 2 together. When you look at example 2, the boundaries are good because if you look at the function 1 over x squared, x cannot be 0. And if you look at both boundaries, negative 1 and 1 are good. However, 0 is between negative 1 and 1. In this case, we have to split this function or this integral into two parts, negative 1 to 0 and a 0 to positive 1 over x squared dx. However, be careful because x cannot be 0. So we are going to change this 0 from negative 1 to 0. We approach 1, 0 from the left, so it's 0 minus. And this one, from 0 to 1, we are going to put plus here. So that's a difference. Everybody be careful. So after we do this, we just need to evaluate each one. So this is negative 1 over x, negative 1, 0 minus, plus negative 1 over x, 0 plus, positive 1. So this will be, we plug next 0 minus in. So it's limit x go to 0 minus negative 1 over x, and then we plug negative 1 in. So give us minus negative 1. This is a constant. Plus, we plug 1 in, so it's negative 1 minus limit x go to 0 plus negative 1 over x. So now we have to deal with these two limits here. So the other two numbers are constant, we don't have to worry. So this gives us, as x go to 0 minus, so x plug 0 in, that gives us infinite. However, 0 minus approaches 0 from the left, so x is negative. So when x is negative, negative, negative give us positive, so our answer will be positive infinity. Plus 1 plus negative 1. When x approaches 0 from the right, x is positive. So this will be negative infinity. So our answer will be infinity. Oh, this one is positive 1, so it's negative 1. Minus 2 plus infinity. infinity plus infinity still give us infinity. This is our answer because the integral gives us infinity, so the integral diverges. There's a special type of improper integration, 1 over x to the p, 1 to the infinity. In this case, if p is greater than 1, the answer will be 1 over p minus 1. It converges. Otherwise, that means if p is less or equal than 1, it will diverge.